Have you ever wondered how a car could possibly see what's around the next corner? It sounds like something straight out of a science fiction movie, right? A car that knows a kid is about to chase a ball into the street before any human driver could possibly react. A car that knows a kid is about to chase a ball into the street before any human driver could possibly react. This isn't magic though, it's science. Some of the coolest science being packed into our vehicles today. We're building cars with superhuman senses, giving them the ability to perceive the world in ways we can only dream of. This technology is designed to be our ultimate co-pilot, a partner that never blinks, never gets distracted, is always scanning the road for potential dangers, making our daily drives safer than ever before. The secret ingredient behind this incredible new vision is a technology called Lidar. Lidar. That might sound complicated, but the idea is wonderfully simple. Think of a bat using sound to navigate in the dark. Lidar does almost the same thing, but instead of sound, it uses light, much faster. Let's get our hands dirty. Break down how this amazing system actually works. At the heart of every Lidar unit is a laser, not the kind you see in spy movies. This is a very safe, invisible laser that pulses millions of times every second. The unit often looks like a small spinning can on the roof of the car, sending light pulses out in all directions. It's like a hyperactive lighthouse casting beams across the landscape. Each pulse travels outward at the speed of light, covering vast distances in the blink of an eye. When a laser pulse hits an object, the bumper of the car in front of you, a nearby tree, a fire hydrant, it bounces back. A very sensitive detector waits to catch the returning light. The core operation is measuring the time for the pulse to leave, hit, and return, then using the constant speed of light to compute distance. Now here's where it gets really cool. The sensor isn't sending one beam, it's firing millions of beams in rapid succession, scanning up, scanning down, scanning all around, creating a full 360-degree scan. Each returning pulse gives 1 point in space, a tiny dot in a 3D grid. Collecting millions of points every second, the computer connects the dots, creating a point cloud. The point cloud is a detailed, constantly updated 3D map showing exact shape and position of every object. This gives the car a superpower, the ability to see things for what they are. A camera might see a dark shape and have to guess. Is it a person, a shadow, a plastic bag? Lidar doesn't guess. It measures. It can tell an object is 6 feet tall, 2 feet wide, and has the form of a human. It can tell a low-hanging branch apart from a high-clearance bridge, measuring the physical world directly. One of the biggest advantages of Lidar is its incredible precision. Accuracy down to a matter of centimeters. The car doesn't just know there's another vehicle in the next lane, it knows the exact distance to its tires, mirrors, and bumper. That level of detail enables safe maneuvers like changing lanes on a crowded highway or navigating a tight parking garage. Lidar is also a huge win at night. Human eyes struggle, cameras need light. Lidar brings its own light source, effective at midnight or noon. But no technology is perfect. The biggest hurdle has been cost. Early units were expensive because of complex lasers, sensors, and rotating mechanics. Prices are dropping as the tech scales, but high-end Lidar remains premium. The other major weakness is bad weather. Fog, heavy rain, a blizzard can degrade performance. Particles can scatter or absorb laser pulses, sometimes blinding the sensor. Engineers test different wavelengths and software filters to remove weather noise, still a fundamental challenge for all-weather autonomy. So Lidar has amazing strengths and real limits. That's why top vehicles use sensor fusion. Lidar cameras and radar together. Fusion lets the car's brain cross-check data and build a robust picture. The result? A smooth defensive driving style that's always vigilant and prioritizes safety. Now imagine this technology is everywhere. Picture a city where every car is equipped with Lidar. Cars aren't just aware of nearby objects, they communicate and share sensor data. Your car would know about a patch of black ice a mile ahead because another car broadcasted a warning. Traffic jams could become a thing of the past. Cars coordinate speeds and routes to flow through intersections like a choreographed ballet. No more stop-and-go driving that causes so much frustration. This interconnected web of sensing vehicles creates a digital safety net over the entire transportation system. Human error causes most traffic accidents. But in a Lidar-dominated future, we could cut those numbers dramatically. The daily commute would change from stressful and dangerous into safe, relaxing, productive, a future where we are free to read, work, or simply enjoy the ride, confident that the tireless laser eye of our car watches over us, guiding us safely to our destination. This isn't just about cool gadgets, it's about fundamentally re-engineering our world for the better. So, how does a car use all this fantastic Lidar data to actually make a driving decision? It all comes down to prediction and planning. The car predicts where every object will be and plans its path dozens of times a second. If a planned route conflicts with a cyclist or obstacle, the computer immediately calculates a safer course, slowing, nudging, or stopping as needed. The result? Safer roads, calmer commutes, and more time for the things that matter. Welcome to the future we're driving toward.